Good evening. We are going to talk about Chapter 1, Plate Tectonics, Section 2, Convection in the Mantle. Make sure at the top of your paper you have that you are in Chapter 1, Plate Tectonics, Section 2, Convection in the Mantle. Very important you have your titles. So, first topic we're going to talk about is the types of heat transfer. You need to know that 3 types of heat transfer are radiation, convection, and conduction. So let's talk about each one of these in detail. Radiation is the first one we're going to talk about. Radiation is the transfer of energy through space. You might have heard of a radiator. It's a heating device that they used to use in homes, and the heat would radiate and fill the room, so it's actually the energy is moving through space. Heat transfer takes place with no direct contact between the heat source and the object, so it's just heating up the air around it. Sunlight, example of radiation. Microwave, radiation. Very, very simple. Conduction is the heat transfer within a material or between materials that are touching. It's called conduction. So, if a hot spoon touches a hot pot, the spoon is going to become hot through the process of conduction. So heat moves from the hot soup and the hot pot to the particles that make up the spoon. So the hot particles inside the soup are heating up the spoon and making the spoon hot. As the spoon becomes warm, that spoon can actually transfer energy and heat to your hand and actually burn you. These particles are near the bottom of the spoon, vibrate as they are heated, so they bump into each other. As particles are heated and cooled, the particles are going to either speed up or slow down. As they're heated, they start moving faster and bump into each other, and this vibration is going to spread that heat and those energy molecules. So, for example, you get sizzling hot fajitas. They put it on this really hot plate, and the heat is transferred to the chicken and to the peppers and everything that's on there. And if you put your fork on there and let your fork rest on it, you will burn your tongue. I'm not speaking from experience, but it does happen. So, convection. This is when heat is transferred by the movement of fluids, okay? So we're dealing with fluids and gases. Convection is the heat transfer by the movement of currents in a fluid. This is important. So, you have air particles moving around, heating things up, okay? During convection, heated particles of the fluid begin to flow. So this would be your soup. Your soup is moving around these particles. And as the soup moves in the pot and those particles are transferred and they're being stirred and moved around, they are going to heat up the other objects. So heat transfer by convection is caused by differences in temperature and density. This is important. Heat transfer by convection is caused by differences in density and differences of temperature within that fluid. Density is a measure of how much mass there is in the volume of a substance. When a particle is heated, these particles are going to move faster and they spread apart. This is why heat rises. As heat rises, it expands, okay, and the heat is transferred upwards. The particles of a heated fluid are going to occupy more space. So, what does this have to do with the mantle and inside Earth? Well, convection currents, okay, are because of the hot liquids in Earth's core and within Earth's mantle are moving, becoming heated up. When you heat, so for example, when you heat soup in a pot, the bottom of the pot gets hot and expands, so it becomes less dense. So that hot soup moves to the top. As it moves to the top, it's going to heat up the particles around it. Well, the air above is cooler than the top of the soup. So that cool air is going to meet that top layer of soup and it's going to start to cool it down. Well, as it cools down, it's going to sink back down to the bottom of the pot. Well, then the bottom of the pot warms it up, particles expand, it rises again, meets the cooler air temperature, sinks again, it creates a circle. So how does this work? Okay, gravity is the force that's going to pull the cooler soup back down to the bottom of the pot. Okay, so gravity is involved here, but this constant flow begins as the cooler, denser soup sinks to the bottom. So the pot and the warmer, less dense soup rises. As it's falling, that gravitational pull is going to pull it back down. So how does this relate to Earth's mantle? Well, what happens is the heat within the core is going to rise up and it's going to expand into the mantle. And as the mantle becomes warmer, it's going to start moving some of the liquid and the softer rocks. Okay, the rocks are solid, but it's going to still move them. All right, so you have these rock particles that are moving within the mantle, and as the particles expand, they're going to rise up, but they're going to hit the lithospheric plate. The lithospheric plate is going to dictate the direction in which they move. So, for example, as it hits the plate, and if there's a little lip in the plate, the lithospheric plate, it's going to push it to the left or the right. And those particles are going to move along the lithospheric plate. And the lithospheric plate is much cooler, so it's going to cool down those particles. And as those particles cool down, they're going to start to sink and fall back down. However, they're going to meet that warm mantle again, and it's going to heat it back up. So let's look at this. So let's look at this, okay? So what I'm talking about here is here's the outer core, and it's this liquidy metal, and the inner core is a dense ball of metal, as we talked about before. It is going to heat up this area here. As this area here gets heated up, okay, it's going to rise up, and it's going to rise until it hits that lithospheric plate. As it hits that lithospheric plate, because this little ridge right here, it's going to dictate whether it goes to the right or to the left. So we're going to deal with this side here. So it's going to move to the left, and it's going to pull these the mantle here to the left. As it pulls it down, it's cooling off. As it cools off, it's going to sink back down. Oops, my bad. It's going to sink back down, and it's going to get heated back up. As it heats back up, it's going to be pushed back up. So what force is driving this? Okay, in the Earth's mantle, large amounts of heat are transferred by these convection currents. Heat from the core and the mantle itself is what's going to cause these convection currents in the mantle. Okay, heat from the core and the mantle is what helps it create it. Geologists think that the plumes in the mantle rock rise slowly from the bottom of the mantle up to the top. Well, as the heat rises, the hot rock eventually cools, sinks back down in the mantle. Okay, that's what you're seeing. It's kind of like that pot of soup. Bottom of the soup, as it gets warmer, it rises up. Top part, cool, sinks. Same thing happens when you're heating up a pot of soup. Convection currents like these have been going on inside Earth for billions of years. Okay, so convection currents are also in the outer core, and this is what they believe to cause Earth's magnetic field. So let's go back and recap just a little bit. Make sure you have this all down. The warm air rises. Okay, as it cools and condenses, it sinks. This is due to density. At the surface, it's going to cool it. As it cools, it's going to sink back down. Gravity is our force. It's going to pull the soup back. The soup is going to pull our convection current back down to the bottom. Okay, a constant flow begins, and so it's going to constantly keep going and going. The convection current is the flow that transfers heat within the fluid. It's transferring that heat. The heating and cooling of fluid changes in the fluid's density and the force of gravity combine to set convection currents in motion. This piece in red is important. The heating and cooling of the fluid, changes in the fluid's density and the force of gravity are what are going to put these convection currents into motion. You need to know that. So let's look at the next piece. Let's recap this. Large amount of heat is transferred in the mantle to create these. Large amounts of heat is transferred by the convection currents in the mantle. Okay, heat from the core and the mantle itself causes the convection currents in the mantle. So, convection currents also are what cause Earth's magnetic field. Questions? Come see me.